So here we are, the final chapter and a final video looking at the main points of chapter 14, multiple regression. So the multiple regression concept is essentially an extension of the simple linear regression tools and procedures we learned in chapter 13. Multiple regression simply sees two or more independent variables describe the dependent variable. So you're trying to predict y using more than one variable, which makes sense. If one variable is good, maybe two can explain more of the movement of y. So just like we saw in chapter 13, there is a general equation. You could see it right here. It's got this epsilon value. Everything is in capital letters. However, we're going to be using a sample equation, which looks like this. The assumptions for multiple regression are exactly the same as they are for simple regression. So by this point, I hope you have them well memorized or you understand them quite well. In addition to chapter 13, or a concept that we didn't look at in chapter 13, is this idea called adjusted R squared. Not really a difficult concept. The equation itself is quite straightforward. The idea here is that in research, you can add as many variables as you need in order to explain your dependent variable. However, if you add too many variables, what happens or what ends up happening is that your R squared starts creeping upwards and upwards in order until it becomes quite close to 1. Now, if you added completely bullshit variables, that will still happen. And so in order to keep researchers honest, there is an adjustment that can be made to R squared to see if the variables that have been added were actually worth adding. So I'll show you an example when we look at the printout, but that's the idea, is you start off with R squared and you adjust it so that it takes into consideration that more than one variable has been used in order to predict it. Finally, there is two ways to test the significance of what the results are. The first way is testing the entire model. We've seen this before. We called it a test for R squared or a test for model. Here in multiple regression, it's simply called the test for the entire model. And second, you can test each and every variable separately. I'll show you what that means in just a second. So here I have your formulas for each test. I know we didn't go over the F-test extensively in chapter 13, so I'm going to do it now, and that will apply for chapter 13 as well. The reason I did that was I didn't want the videos for chapter 13 to be extremely long. And so let's flip over to the printout. First things first, immediately we know it's a multiple regression. There are three variables, x1, x2, x3. You heard me correct. This is x1, this is x2, this is x3. This is just the intercept. Please don't think that that's the first variable. You can be misled and get some answers wrong if you do. Your coefficient is essentially, your coefficient column is essentially the answer to the question, what is the regression equation? So in this case, y hat is equal to an intercept of 39.31 minus 0.24 x1 minus 0.47 x2 minus 0.22 x3. That is your regression equation. And so looking at it, I didn't give you too much of a description, but looking at it, you can see here that it's actually the same problem as the one we saw in chapter 13. We're looking to predict the usage, the natural gas usage for a city using degrees Fahrenheit, the average weekly temperature. And so what I also added was the oil price as well as the natural gas. So if someone asks you, please explain the second variable or the coefficient for the second variable, you say that Holding other things equal, this is a very important statement when you are dealing with chapter 14, multiple regression. Holding all other variables equal, for a 1 unit change in oil price, the consumption of natural gas will drop by negative 0.47 millions of cubic feet. In other words, 470,000 cubic feet of natural gas. So that's the correct statement. Holding other things equal, Y will change by this much if X changes by 1. Of course, the column next to it is the standard error. It tells you the standard deviation of every slope as well as the intercept. And so if you take your slope, you divide it by the standard error, you should get your t-stat. Immediately, you should recognize which variables are important and which variables are not important. The variables that are important are always going to be the ones that have the highest t-stat. So in this case, by pure coincidence, it's going to be the first one. It has a t-stat of 8.17 or negative 8.17. It's an extremely high test statistic. Anything larger than 2.5 or 3 is considered significant. And here's the hapstance. So by hapstance, by the stroke of luck, oil prices, the second variable is actually the second most important variable. It has a test statistic of 4.19. And then finally, natural gas actually is not significant because it's got a test statistic of only 0.19. So that is pretty close to 0. Remember your critical values, numbers such as 1.645, 1.96, 2.57. You can see that they are much larger than 0.19. And so basically natural gas, the variable natural gas, is an insignificant predictor of the consumption of natural gas. And so if this was a real job, what you would do is you would take out that variable and redo the entire process again, but just using Fahrenheit degrees and oil prices. And so looking at the p-values, it confirms what you've just discovered using the t-stat. The p-value for the first variable is pretty much close to 0. The second one, because it's slightly less important or significant, it has a slightly higher p-value, so here at 1%. And one more time, you can see the upper and lower 95 and 99%. We can do the 95 and the 99% will be an extension of that. It's no big deal. And so you can see that the intervals don't contain zeros for the ones that are significant. But look at this one. We'll use a different color. The intervals contain 0 for the variable that is insignificant. Looking at the regression statistics, don't worry so much about multiple R. It's not going to make much sense in a multiple regression because there are many correlations in multiple regression. You have to do a correlation. Correlation is always bivariate, meaning there's always two entities that are being compared. So in a multiple regression, you will see the correlation coefficient between y and x1, y and x2, y and x3, x1 and x2, x1 and x3, and so on and so forth. So it needs a matrix, and therefore multiple R really doesn't make much sense. We have our R squared. It's a pretty decent R squared. 98% of the movement of y has been explained by the x's that are chosen. Here is the new concept, adjusted R squared. We can see that adjusted R squared is pretty much close to or almost the same as R squared. So even after the adjustments, it's still pretty high. So it means you added some pretty good variables. Doesn't mean you added all the good ones, but you added at least some good ones. And this is what we've discovered here. You've added a really, really good one in oil price, but then you added a bad one in gas price. Regardless, the R squared adjusted turns out to be pretty high. You still have your standard error, so this is your standard deviation of the error terms. You still have your observations, similar as before. These are the degrees of freedom for the multiple regression. So as always, this is k, this is n minus k minus 1, and this is n minus 1 degrees of freedom. Here's your SSR, here's your SSE, and this is your SST. Notice that they add up to each other. They add up to SST. These are the MS, so 25.8 divided by 3 should give you 8.3 and should give you 0.12 for your residual. So this leads us to the F. So let's go ahead and do the F test for completion's sake. So if the question says, test the significance of the model, here's how you do it. And you can do this for chapter 13 when you're testing for the significance of R squared, but it is especially used in this chapter. So step 1, the hypothesis, HO, B1 is equal to B2 is equal to B3. There's only 3 B's in this case. It's equal to 0. HA at least 1 BI does not equal to 0. So you're saying at least one of them is actually different than 0, meaning one of them is important. Step 2, you're going to find the critical value. And so the critical value is going to be F alpha. This will always be a one-tailed test, so it's going to be F alpha, comma, D1 over D2. There's 2 degrees of freedom. And so the F test looks something like this. I'm going to use the chi-squared test and or the chi-squared distribution and change the value. They are very similar in shape. And so you're going to have a cutoff mark here. This is going to be your F critical. Which is equal to, let's look it up. So let's use, for example, let's use 1% in this case. So we're doing F 1%, comma, D1 is going to be K, and then D2 is going to be N minus K minus 1 degrees of freedom. So in this case, it's going to be F 1%, 3 divided by 4, which is equal to. Let's look it up. You have the F table right here. This is mine, but you can use whichever one you like. This column right here is the one we're going to use. And we're going down. So this is, you can see here, degrees of freedom in the numerator. So for us, D1 was 3, D2 was 4. So it could be any of these numbers. Or essentially this one here. That doesn't look so good. So any of these numbers could be the critical value. If we're using 1%, which is this one right here, so the answer should be 16.69. So now that you've set it up, you can actually conduct the test now. So due to rounding, you may not get the exact answer, but your test statistic is 71.69, clearly in the rejection zone. Therefore, this model is significant. So once again, I'd like to emphasize that you can test the entire model one shot by using the F test, or you can test individually each variable to see which one is significant, and then we determine that the ones that are the highest with the highest t-stats are going to be the most significant. This one does not have a very high t-stat. In fact, it doesn't cross any of the main critical value lines, such as 10%, 5%, or 1%. So this variable can be removed from the equation, and it would be redone with one less variable to play with. So this has been a video showing you the printout for multiple regression. Super important to learn. Not very difficult because it's an extension of chapter 13. The only new additions are the calculations of adjusted R squared, and I went over how to calculate in F-test for the significance of the model. Thank you very much.